In two of the previous videos, we looked at the key features of a quadratic and then the key features of a cubic. And because these are two of the most basic polynomial functions, also including the linear, and we'll see that a lot of the things that we have for x cubed are same for linear, we want to kind of compare and contrast what is the difference when we have an even power versus when we have an odd power. So we're going to compare and contrast the key features of a quadratic to a cubic. As a quick reminder, the cubic function looked something kind of like this, and my quadratic function looks something kind of like this. So here we have that basic U parabolic shape, and here we have kind of this squiggle. It goes all the way down and all the way up. So first, I'm going to start with the things that they had in common. For all polynomials, we're going to find out that the domain is always negative infinity to infinity, because any number can be raised to an exponent. So any number can be plugged in. For each of them, because any number can be plugged in, we can plug in 0, which is going to give us our intercepts, and 0 to anything is always going to equal 0. So each of them have an x and y intercept at 0, 0. We can see that here, and we can see that here. Now, something that is even cooler that wasn't necessarily pointed out in the other functions or the other videos, this is not necessarily a key feature, but it's something that is really cool about basic polynomials, is there's one other kind of exponential phrase like this that is true no matter what, and that is 1. 1 to any power is always equal to 1. And so that is the other point that every single one of these is going to share, is the point 1, 1. Last but not least, the other thing that I see is both of these are in the first quadrant. And when I have a graph that is in the first quadrant coming up from 0, 0 in the first quadrant, that means that I'm going to see that they are increasing here. So both of them are increasing on the interval of 0 to infinity. So from 0 to positive infinity, my graph is going to be increasing. However, that's pretty much where my similarities stop. So now we're going to talk about, well, what makes them different then? Because they are polynomials, they should share a lot of information, but it's not always going to be perfectly the same. So they did share a domain. Let's talk about their range. Here I can see for a cubic, this one goes all the way down. So we said that the range for a cubic is negative infinity to infinity. However, we saw that the quadratic has a very obvious stopping point. So the range for the squared one is going to be 0 to infinity. So that is something that they have in different, in contrast of each other. We said that they did share their intercepts, so we don't need to talk about that. They share this point 1, 1, which is pretty cool. They do not share the point -1. So if you wanted to add that, we could. This one has the point -1, -1, versus this one has the point -1, 1. So that even power turns all of the x values positive, versus for a cubic, that odd power keeps all of the negative numbers negative. We also talked about their symmetry. We said that this one had a rotational symmetry. That means in order to make one half lie on the other, we have to actually rotate a piece of it. So we had to cut it here and rotate it 180 degrees, versus this one has perfect symmetry across the y-axis. It has that line of symmetry. So it just has symmetry about the y-axis. We also discussed increasing and decreasing intervals. We said for a cubic, it is constantly increasing. So it's increasing from negative infinity all the way to infinity. Once again, it has that shared bit at 0, 0. Versus the quadratic actually starts going down before it turns around to go up. So it increases that 0 to infinity, but it decreases from that negative infinity to 0. So that is kind of the contrasting piece there, is that decreasing interval. One of the last pieces I want us to talk about before we fully move on is kind of the rate of change. So we noticed that when we were looking at these, the cubic one got fast quick. It went 1, 1, 2, 8. So that jump was 7 pieces. The next one would actually 3, 27. And that's an even larger jump. versus the quadratic went 1, 1, 2, 4, 3, 9. So when x is larger than 1, x squared grows slower. Because notice we were only looking at x is greater than 1. So here, when x is greater than 1, x cubed grows faster. One of the things that we didn't do in the other videos is look at fractional numbers. So I'm going to take some fractions here and I'm going to say, well, what about 1/2 cubed? Or what about 1/3 cubed? 1/2 cubed is going to give me 1/8. 1/3 cubed is going to give me 1/27. We still see that quick growth, but it's making my numbers smaller. It's making my numbers smaller quickly because it's turning these into fractions. Versus if I did 1/2 squared, I get 1/4. If I do 1/3 squared, I get 1/9. I'm still getting fractions, but at a slower rate. And so what we really want to talk about here is that when x is between 1 and 0, the x cubed values are smaller. The x cubed values are smaller because they're quickly becoming these large fractions. And we know that when that denominator is large, we're getting closer and closer to 0. Versus in that same range, so from, or same domain, if you want to talk about that way, but 0 to 1, our x squared ones are going to be, the x squared values are larger. And when I'm saying larger and smaller, I mean in comparison to each other. And so those are some of the main points that we can talk about when we're talking about comparing and contrasting x cubed and x squared.